All right, in this lesson, we are going to talk about radical expressions as rational exponents. Okay, and so as we do this, we do want to review our properties of exponents because they directly translate to properties of radicals. And so one property of exponents is that if you are multiplying two expressions with the same base, you add their exponents. If you are dividing, you subtract the bottom exponent from the top. Okay, here in the multiplication example, you're gaining copies, whereas when you're dividing, you're losing copies in that multiplication strand. Okay, if you see a negative exponent, that means you need to write it in the bottom of a fraction. That means it should have been written in the denominator, not the numerator. Anything to the 0 power is 1. If you have two exponents on one base, that's when you multiply them. Okay, so here, if you have the base written twice, you're going to add. If you don't have the base written twice, you just have two exponents on one base, that's when you multiply them. If you have a product or a quotient, you can distribute the exponent. Be very careful when you distribute the exponent. If there was a plus sign between those, you could not distribute. So that doesn't translate to binomials. We've talked about that. Okay, and so only if there is a product or quotient can you distribute the exponent outside the parenthesis. Okay, and then something we've talked about is if you see a 1/2 power, that's square root. If you see a 1/3 power, that's cube root. And so in general, if you see a 1 over n power, that's the nth root. Okay, and so ones we have talked about is 1/2 power, that's square root. If you see a 1/3 power, that is the cube root. And so it extends to greater power. So 1/4 would be a 4th root, and so on. Okay, and so here I have square root is a to the 1/2, nth root. And then in general, if you see something other than a 1, that number in the numerator is still the exponent. Okay, and so a way I remember this is that the top number is the power, and then the bottom number is the root. Okay, and so to rewrite that, it's the nth root of a to the m. And you could do those in either order. Often it's easier to root the number and then raise it to the power, so it's getting smaller than bigger. And so the cheesy way to remember this is that roots are in the ground, the denominator, powers are in the sky. Roots are in the ground, powers are in the sky. Okay, so for these first examples, we are just going to practice rewriting each radical expression using exponents. And then if we're given the exponent, we are going to rewrite it using radicals. Okay, and so here we have a rational exponent, 1/2. That is the same thing as square root. Here we have a 3/4 power, and so 3 is the power, 4 is the root. And so that gives me the 4th root of the x raised to the 3rd power. Okay, I always put the root first. You could put the cube first, but if you can imagine, if you cube a number and then try to take the 4th root, that's going to be a lot more challenging because you're going to be trying to take a 4th root of a big number. Okay, here we have a negative exponent. Don't change anything until you use the property to move that to the denominator, and then you can rewrite a to the 1/2 power as square root of a. Okay, same thing here. I have a negative exponent, so that a to the positive 5/3 should be in the denominator. And then now 5 is the power, 3 is the root. So that means I'm dealing with the cube root of a raised to the 5th power. 3 is the root, 5 is the power. Okay, next we have this negative outside, and so when we convert this to a rational exponent, it needs to stay outside. So that's why I'm putting parentheses, but leaving the negative outside of them. Okay, here 5 is the power, so that's my numerator, and 4 is my root, so that's going to be the denominator. Okay, and then if the negative is outside, they'll often just leave it without parentheses. In order to be inside, you would need the parentheses written. Okay, so here the negative is inside. Okay, and so 2 is the power, and 5 is the root. And what we are raising to the 2/5 power is a negative b. Okay, so that's why I'm using parentheses this time, because the negative is inside the radical. Okay, next we're going to practice simplifying numbers being raised to rational exponents, because in the next lesson we are going to solve equations that have rational exponents, and we need to be able to simplify these without using a calculator. Okay, and so starting with 1/2 to the cube to the third power, or 1/2 cubed, you cube the numerator and you cube the denominator, and so that gives me 1/8. Okay, -3 squared becomes +9. Anytime you square a negative, that's -3 times -3, so it's going to become positive. The negatives cancel. Here, notice the difference between 8 and 9. This negative is not in a set of parentheses, so we are only squaring the 3. And so that negative is going to stay there, and then we're still going to get 9. This is why when you type this expression in the calculator tells you it's -9, and what people are trying to type in the calculator is -3 being squared. So a lot of my students argue that -3 squared is -9 because that's what the calculator told them, but they're not using the parentheses. So just be careful and know which case you're wanting. Okay, here we have 125 to the 2/3 power. Okay, and so remember that 3 in the denominator is the cube root. Okay, so I'm going to root it, then raise it, because that's going to be easier for us. Okay, so we are going to take the cube root of 125, which is 5, and then we are going to square it, which gives us 25. Okay, you can see how it would be very difficult to square the 125 first and then try to cube root. There's no way I could do that without a calculator. Okay, here we have a negative, but that negative is outside the radical. Okay, there's no parentheses here, so don't make your own. So I'm gonna leave that negative out, and then I see that I am dealing with a square root, and then we are going to raise it to the 5th power. Okay, so my radical serves as my parentheses, and so square root of 4 is 2, and then we still need to raise it to the 5th power, and then 2 to the 5th power is 32, and then we still have that negative. All right, now we are dealing with a 4th root of 81, and then we are raising that to the 3rd power. Okay, when you're taking a 4th root, you square root it twice. And so square root of 81 is 9, square root again is 3. So the 4th root of 81 is 3. And then we still need to raise that to the 3rd power, which would give us a 27. Okay, here, like I said, you can do the cube root before you raise it to the 5th power, because if you don't have a calculator, raising -27 to the 5th power is not easy. And so you can reverse the order and do the cube root of -27, and then we'll raise it to the 5th power. So the cube root of -27 is -3. And then -3 to the 5th power, I think, is -243. because 81 would give us negative 3 to the 4th power, and then just multiply that again by 3. And then anytime you raise a negative to an odd power, it is still negative. Anytime you raise a negative to an even power, it would become positive. Okay, here we are doing cube root of the negative 8, and then we are raising it to the 5th power. So that gives me a negative 2 raised to the 5th power, which is negative 32. Again, raising a negative to an odd power stays negative. Okay, next, I see a negative exponent. So don't do anything until you do that property where it means our 27 to the positive 1/3 is at the bottom of our fraction. Now I recognize that 27 to the 1/3 is cube root. And then I know the cube root of 27 is 3. So that expression simplifies all the way to 1/3. Okay, same thing here. I need to write the 32 to the positive 3/5 power. And then that 5 in the denominator is my 5th root. And we've been working with 2 to the 5th power, so we know the 5th root of 32 is 2, and then we're going to raise it to the 3rd power. So 2, and then 2 to the 3rd power is 8. So a lot of these may seem intimidating to do in your head, but the more you do the practice, the ones that are going to show up on the test are the ones you've seen in the practice. So we know by now 2 to the 5th is 32. If you didn't know that before, you know it now. Okay, last one. We have 4/9 the negative 1/2, so that means I have 4/9 to the positive 1/2. Okay, and then we recognize that as square root. And then we square root the bottom and the top, so that would give me a 2/3. And then don't leave a triple layer fraction like that. This is a keep, change, flip. And so keep the 1, change your division to multiplication, and then flip your second fraction. And so this simplifies to 3/2. Another thing that we could have done is when you see a negative exponent, that also means reciprocal. So instead of writing it as a triple layer fraction from the beginning, you could actually just flip the fraction inside a negative exponent and then change the exponent to positive. That's another trick, and then it would have been a lot more straightforward to give us that 3/2. So either way you look at it, same answer.